Now, let me ask you a question. How many of you have thought about the role intelligent technologies are playing behind the scenes in powering entire industries today? As we explore that idea, we turn our focus to a sector where the transformation is happening at an incredible pace. Our next session, Impact of Artificial Intelligence on the Energy Business. We'll take a closer look at how advanced technologies are reshaping operations, improving efficiency, and influencing decision-making in the energy space. Please join me in welcoming Andreas Fornwald, CEO and Board Director of StarCharge, to the stage. He's just getting mic'd up. He'll just be here in just a moment.
Thank you very much. Thank you very much for the great introduction. I will walk you through the energy constraints due to the artificial intelligence. First, a short question. Do you have your phones charged? I hope so, because we are living in a constrained world, and the Strait of Hormuz is everywhere. The Strait of Hormuz is in front of every artificial intelligence data center, because we are running out of energy. So you see the constraint on the modern data hierarchy is huge. When we implement the new chips, and you see them, the new chips in the data center, we need far more energy. We need switch gears, microgrids, UPS, switch, and to get the energy there. And the congestion bottleneck, the Strait of Hormuz is there, the red one, and it's everywhere. So the US will need to increase their power production by 20 to 25% in the next year. And we need all the power we can get. That means we will have to revive nuclear, we have to use natural gas, and of course, the renewable energy. And we will need new batteries. That's my job, what I'm doing at StarCharge, new modern batteries with lithium ion that you have in your phones will be deployed in more than 90 gigawatts. That's 9 trillion of phones. 9 or even 90 trillion of phones on the grid to support the grid. So the landscape, the 2026 data center landscape, you see, is the big power plant connected to the landscape and then connected to the tower or to the fiber optic that gets the data to you. We have the hyperscalers, the whales, the big ones. They use the Google Tensor processor, they use the Amazon Trainium, so all artificial intelligence special processors, and they use the Vera Rubin from NVIDIA. NVIDIA became the world's biggest company, the world's most valuable company, 5 trillion of worth, because of these chips, because so many chips are used in the data center. Now I will show you how this looks like. They are in a rack, and they need not only energy, they need also cooling. They become really hot. And because they are so power hungry, we don't put on the chips like we use in your computer or cell phone, 5 volts, 12, 24, 48 volts. We power them with 800 DC volts, so very strong power network. That's how it looks. This is how the cabinets looks, and you see how big are the centralized PSU for cooling. Liquid cooling and all the cooling is another energy hungry unit that we need to feed. Not only the power for the CPU, but also to cool them. So you see, here are the hyperscales. The hyperscales are the big data centers from Amazon, Microsoft, ChatGPT is using, or these hyperscales. They have extreme power consumption. One rack that you saw before can consume up to 100 kilowatt. 100 kilowatt is a block, 10, let's say 10 one-family homes. That's a lot, only for one single rack. And they still have a big latency in hours, delays. Sometimes when you click for a word on ChatGPT, that doesn't come because the energy is not there. If you have latency, the energy is not there, that's why it's not coming. Then we have the co-location, the medium-large data centers that are connected next to the powered land where people find a way to connect to big transformers, high voltage, and design auxiliary data centers. And of course, the edge and microgrids, which are very quick, small data centers, but you need thousands, 10,000s of them. So we have the density over size with 100 kilowatt racks with 800 volt DC. We have the latency war. The latency war is that your AI responds instantly. The strategic repatriation. The other challenge is that some AI need to be very close to the banks, but because it's sensitive. It's all about cybersecurity. So you cannot put it in a big hyperscaler, in a big data center somewhere in North Dakota or in Mississippi. And you have speed to power. The construction of a data center, we need the data centers yesterday. The 2-year construction bottlenecks that we have, it's just 2 years to the permitting, are completely unfeasible today. And we need, some try to launch mobile data center, the co-located data center, just for interim. The energy bottleneck. You see, during the cloud era, the energy consumption of data centers were almost constant. 2023, the AI era started, and that's how the energy consumption of the data centers increased. When we put one word in Google, we generally use for the search, complex search, 0.3 watt. When we put one word in ChatGPT, the ChatGPT will use 10 times more energy. So when you click ChatGPT, you use 10 times more energy of the data centers than on Google. And of course, you use more words than in Google because you describe a problem and it comes back with a full text. So we have 100 times at the end. So a data center, a hyperscaler, consumes more than a midtown. So if you drive to Barstow, to Los Angeles, I promise you Barstow has less consumption than a big data center, the whole city of Barstow. The bottleneck is in the local utility, in the grid connection. That's why a lot of communities in the United States, especially in Pennsylvania, Virginia, where is the data center alley, are very concerned with the price of energy that is growing exponentially because of the consumption. Another example how big the consumption of data center is, that the world data center consumption by 2030 will be higher than the whole total energy consumption of Japan. And we have the reliability gap. Even if we build the energy, the power generation as soon as we can with wind, solar, we still have the reliability gap. Wind and solar is not permanent, it's intermittent. So we need to put gas turbines, we need to come to fossil power, we need to go back from the renewables. Renewables will not feed enough. We need an accuracy of 99.999% and reliability. That's why nuclear is coming back. United States have 10 nuclear projects that are under approval, and one will be started soon. So we need that because we are in a competition. AI is the strategic competition to China. What we had with the Soviet Union, with the Russian in the ballistic missiles, the competition is now going on AI. Who will win the AI race? We are far ahead of China, but our bottleneck is the energy. China has a lot of coal power plants. They built nuclear power plants in 2 years, one by one, so they do not have the permitting process. But we have the chips. How to bring the grid to the GPU, to general processing unit, is the artificial intelligence is not only consuming energy, and that's a good thing. It's a reflexive power. It's also improving the grid. Thanks to artificial intelligence, we have the neural grid. So artificial intelligence will also make the grid far more efficient. So the paradox of AI revolution is that the old grid, which is highly complex, decentralized, and burdened by the loads, without an orchestrating layer, failure is inevitable. The imperative is a new grid controlled by artificial intelligence, which will not strain the grid. It is a fundamental mechanism required to stabilize it. It uses also artificial intelligence. So artificial intelligence is used also to stabilize the grid. So it's a necessity. We have 4 levels of supporting the grid by artificial intelligence. The high precision renewable forecasting. The forecasting will eliminate additional idling power generation and especially the spinning reserve. Probably a few of you knows that at the US there are 500 gas turbines that are rotating permanently to avoid blackouts. Small gas turbines, generally LM 2500 or LM 4000 for GM, smaller gas turbines, the size of an airplane engine that are connected to the grid, rotating at to be able to synchronize with the grid in milliseconds. This can be eliminated by forecasting. The level 3 is building the virtual plant. The virtual plant acts as a conductor of an orchestra. The orchestra being all the plant we have and conducting them and create a single massive battery where we can tap our power need. The last level that we implement now is the self-healing ecosystem. So due to the predictive maintenance, due to the algorithms and deep learning in artificial intelligence, we can predict which components will fail. We can now predict when a blackout can come. We had last year the Spanish blackout. I just implemented in my company an algorithm that could have predicted that one, the Spanish blackout last year in May, and deploy the right assets at the right time. So the self-healing ecosystem will come. So artificial intelligence, in a nutshell, is not only a huge power consumer, but is also a healer for the power systems, for the power grids, and for a power distribution. Yeah. I'm happy to take questions.
Yes, sir.
Yes.
I noticed in your slide, and you talked about this a little bit, you know, the infrastructure that we have needs a lot of work in order to make this happen. What kind of things do you think need to take place in order for that to really come to fruition?
We need to put more generation, more intelligence in the grid, like you see here. That's actually answering your question. The millisecond reroute, so the artificial intelligence can instantly reroute the grid so we don't have a blackout and isolate the failure. And we need new resources. We need nuclear power plants, small, medium nuclear generators. So here the Navy can help us with their submarines. They have the right generators in the submarines or in the aircraft carrier that we can use for civil. We need all the power we can get. Imagine, we need the power of Japan on top of what we have, the whole power of Japan to power this grid. That's where we have, so the artificial intelligence in the electric grid has a bigger impact than the Strait of Hormuz. They are next to UAE and Iran on the oil markets.
I have a follow-up question. I don't want to hog it. So do you see enough movement in all the industries that deal with power generation? And if you do, what kind of time frame are you seeing that it's going to take to get to where we need to be?
So it depends. There is also talk about the AI hype, that it will implode like the internet in 2000, which I do not believe because it's a strategic investment. But the current forecast is to get it done, we need at least till 2032, so another 6 years. Just go from we need gas turbines. Vernova, GE in Atlanta, General Electric has now rights or has their books, the order books filled in 2031. Siemens to 2030, Mitsubishi 2030. So you cannot get a gas turbine before 2031. You cannot get a small medium reactor because they are not yet certified. It's another process of 5 years, nuclear. So solar you can put, but solar is very intermittent, so you need batteries that you can do in 2-3 years. So there will be intermittent solutions. There will be also a lot of creative solution. This space, and that's why I'm telling to you, this space needs creativity. It needs every mind who can solve this problem and send something to the power grid. The power grid is completely under strain. Sure. Yeah. Yeah, I know. Yes. So you live in California. So yeah, California is a special case. I drive an EV. I charged yesterday EV, and I said, hey, I'm not putting gallons. I'm putting energy because I charged my EV yesterday for $75, one charge in California. Yeah, I said, what am I doing here? It was a fast charger at very bad time, but what we need to do is not only improve the grid, we need to mandate the artificial intelligence, this big investment, Oracle, hundreds of millions, hyperscaler, to build their own power plant, their own co-located power plant, to build their own nuclear reactor. We'll have private small nuclear power plants. That's the future. Yeah, the FERC is to... No, you cannot build in the United States, generate a power plant if you don't go by the regulation, by the... because I don't think you can put in your backyard a small nuclear reactor, even if you own one. No, the regulation will be there, but we need to make an effort. And that's why I'm presenting here, because it's a lot of leadership needed, a lot of manpower needed, a lot of creativity needed. This is a space which is exploding. We're all looking to the TV and see, wow, the 20% of oil production that are stuck in the Hormuz. We have here 25% of electrical production that are stuck in our grid, which we need. Yes, every bit of energy is helpful. And people who say we need renewable are wrong. People who say we need fossil are wrong. We need both.
Yes, I have a quick question for you. I noticed in an article the other day that because of the permitting problems, that there is a lot of thought going into building ships and barges, with nuclear power on them. One, they can control them. Two, they can move them. And three, they just build the infrastructure on the river or the port in order to take advantage of the power and add that to the grid. Have you seen anything about that?
I don't know much about that. I just hear that there was an old project in the Soviet Union for a nuclear ship that is driving around Africa, feeding African countries, which failed miserably because of safety. But that's a good idea. Everything. So the grid needs power like crazy. Everything that goes, and it needs stabilization with batteries. Batteries are the best way to stabilize the grid if you have too much solar and wind, which are intermittent. So we need that. And that's why I ask you, charge your phone every day, because sometimes we'll have a blackout. If we don't go quick on that, and if we connect all the data centers, it will happen. The good thing is that artificial intelligence also helps. It helps us to do an optimized grid. We can get with the latest model of artificial intelligence, we can optimize the grid by 20%. So we need 25, 30, we optimize by 20, so there is still a gap, but not so big. But first, the AI has to work. To work, it needs the energy. So what is first, the chicken or the egg? Now, every power, nuclear power is a good option because it's actually, in a big sense, renewable power, if you know what to do with the nuclear waste. It's not polluting power. I don't call it renewable, I call it non-polluting power. And yeah, it's a big option because it's a lot of power. The question is that, and that was debated by the Department of Energy, and I talked with Chris Wright. He has a lot on his table and doing a fantastic job. The question with nuclear is safety. Safety for big nuclear reactors is pretty known. Safety for smaller is same, but does it make sense economically to have the same safety regulation for a small reactor? Probably not. So we need to find the size of a nuclear reactor where it makes sense. Sure. We're looking for new technologies, correct, and we're looking to enhance the old technologies that we have and to use them properly, efficiently. So we have a lot of grids in the United States that are losing power. Old grids, old cables, just a simple thing. If you replace the old copper cables, you already have 3 to 5% more energy.
And with that, we'd like to thank Andreas for that wonderful presentation. We'll be moving on to the awards ceremony.
I'm here